science classes, we measure many things. One of the first things that we learn to measure is mass. We generally use a digital balance. Another thing we measure is volume. All matter is made up of mass and volume. There's a few other things that we commonly measure, such as temperature, length, and time. A new thing that we're going to be measuring in chemistry class is the amount of a chemical. The amount of a chemical is a unit called moles. We'll hear more about those later on this year. All of these measurements can be taken in the metric system. Those metric systems are the things that you've learned about where you have lots of prefixes. So for example, 1 gram could be equal to a certain amount of kilograms. A kilo is always 1,000 times bigger. So 1 kilogram is 1,000 times bigger than 1 gram. You would need 1,000 grams to equal 1 kilogram. The other prefixes that we want this year are all smaller. So deci is 10 times smaller. So a deciliter is 10 times smaller than 1 liter. Centi, for example, a centimeter is 100 times smaller than a meter. And then finally, milli is 1,000 times smaller. When we're changing between these prefixes and between these measurements, we're going to use a system called dimensional analysis. Now, there's quite a few rules to it, but they all are going to make sense in the long run. So dimensional analysis is a way to change units of the same type, like minutes to seconds, because they're both times, but not a mass to a length. We're going to go through these rules, so write them down for a minute, and then I'll show you how to do it with the examples. We write what we're given on the left, that's already done for you. On the far right, you're going to write the unit you are solving for, also done for you on this page. Steps 3 and 4, where you're actually going to be writing. We're going to fill it in kind of an up-down fashion. The unit we start with, the unit that we need. We're going to fill in some numbers, and then we're going to be able to cancel units, multiply up, and divide. Pause the video, copy this down, and then move on. When we want to convert 25 kilometers to meters, we need to remember that every 1 kilometer is 1,000 times bigger than a meter. So following the rules of dimensional analysis, this is what it's going to look like. This is essentially a way to write fractions without having to actually write fractions. Anytime we have a unit that's on top, we're going to write that same unit on the bottom of our, we like to call them fences instead of fractions. Okay? The unit that we want, which it says on the right of the page is meters, is going to go on the top of our fence. Once we do that, the first number at the beginning doesn't even matter. So we're going to hide it for a second. What we want to know are how meters and kilometers relate to each other. Well, we know kilo means 1,000 times bigger. So 1 kilometer is 1,000 times bigger than 1 meter. So we write 1 with the bigger number, and the number for the prefix 1,000 goes with the smaller object. So every 1 kilometer has 1,000 meters. Once we do that, we can hide or unhide the original number. That original number is now going to go into our math. Anything that's on top of these fractions will multiply together. Anything that's on the bottom is a division. So when we plug this into our calculators, we're going to write 25 times 1,000 divided by 1. Our answer will be 25,000, and our units will be the units that don't cancel out. Now when we cancel units out, anything that's the same on the top and the bottom can cancel out, so kilometers and kilometers will cancel out. the only unit we have left is meters. Therefore, our answer is 25,000 meters is equal to 25 kilometers. Now, you may have learned some other methods to do this, but you're going to have to use dimensional analysis a lot this year, so this is the only method that we consider acceptable in chemistry class. So let's look at example number 2. All the dimensional analysis always starts by drawing this fence and writing the unit that you see on the bottom. So we see liters, so we're going to write liters on the bottom. The next thing we want is the unit on top to go where it belongs. So the unit we want is milliliters, because that's what the problem says to solve for. Well, now, just like before, I'm going to hide the original number, because that information does not matter anymore. What matters is how liters and milliliters relate to each other. So the prefix milli meant smaller. So the number that's not 1 always goes with the smaller prefix. So we're going to write 1,000 with milli, because milli is 1,000 times smaller than 1 liter. So I'm going to write 1 with liter. Once we've done that, we can actually solve our problem. So I'm going to unhide our number. The top is multiplication, and the bottom is division. So we're going to type into our calculators 0.008 times whatever's on top divided by whatever's on the bottom. And we will get 8 for our answer. All of the units that were on the top and the bottom cancel out. So liters were on top and bottom, so they cancel out. The unit we have left is milliliters, so our answer is 8 milliliters. Looking at example number 3, we're going to draw our little fence. The unit that we have on top right now is grams, so we're going to put that on the bottom. And our paper says we want to convert this into kilograms. So whatever we want will always go on top. Once we know those units, we're going to hide the number, because that number doesn't matter anymore. So we need to know how grams and kilograms relate. Well, kilo means 1,000 times bigger. So whatever's bigger always gets a 1. Opposite side, the smaller side, will always get the number for that prefix. So kilo means 1,000. We're going to put 1,000 grams. Once we fill that out, we're going to unhide the number, because now's the math part. Multiply what's on top, divide what's on the bottom. 430,000 times 1 divided by 1,000 will equal 430. We cancel out any units that were both on the top and the bottom, so grams and grams will cancel out. The only unit we have left is kilograms, and therefore we have our answer. For our last example, we have 2.5 hours, and we need to convert hours into minutes. So again, we're going to draw our fences. We need to cancel out hours and convert to minutes. So what we want to get rid of goes on the bottom, what we want goes on the top. Now once again, we're going to hide just the beginning part so we know how minutes and hours convert. Now minutes and hours aren't metric like the other ones, so sometimes we have to know other conversions, but we know how hours and minutes relate to each other. We know that every 1 hour is made up of 60 minutes, and minutes are smaller than hours, so that's why we put 60 with minutes, because they're smaller. So every 1 hour has 60 minutes. That's why I put the 1 with hour and the 60 with minutes. Once I figure that out, I can unhide my original number. Everything on top gets multiplied, everything on the bottom gets divided. So 2.5 hours times 60 divided by 1 is going to give me 150. I know it's minutes because hours are on top and bottom. They cancel out. The only unit I have left is minutes.